equations in standard form, but this time given the center at HK. So the standard form or the equation that we're going to use is x minus h, quantity squared, plus quantity y minus k squared is equal to r squared. So those are the examples of circles with center at HK. First example. Give the standard equation of the circle satisfying the given condition. Number 1. Center at 2, 3 and radius of 6 units. So now, if the center is at 2, 3, in what region can you locate the center? So that will be in first quadrant. Then the length of the radius is exactly 6 units. So we all know that the equation to use is x minus h squared plus y minus k squared is equal to r squared. Now, since the center is at 2, 3, so that will represent your hk. The x-coordinate is your variable h, while the y-coordinate is your variable k. And of course, r refers to the radius. By substitution, so we sub the value of h, that is equivalent to 2. We sub the value of k, that is 3. And the length of the radius, that is 6 units in our main formula. So now we have quantity of x minus 2 squared plus quantity of y minus 3 squared is equal to 6 squared. Next, we evaluate the right side of the equation. So the left side as is. So that will be the quantity of x minus 2 squared plus y minus 3 squared is equal to 36. Drawing the circle, again, we begin with the center at 2, 3. Then with a radius of length 6 units. So this will be the circle in our first example with center at HK. Example number 2. Give the standard equation of the circle satisfying the given condition. Center at negative 2, negative 4, and radius of length 3 units. So again, we use our formula. Then we identify the center. We all know that the center is at HK. So H has a value of negative 2. K has a value of negative 4. While the radius has a value of 3 units. Evaluating this equation, so what is now x minus negative 2? X minus negative 2 will give us x plus 2 squared, while y minus negative 4 will give us quantity y plus 4 squared. Then 3 squared will give us 9 units. So our final answer becomes quantity of x plus 2 squared plus the quantity of y plus 4 squared is equal to 9. Drawing the circle in our example number 2, we begin with the center at negative 2, negative 4. The length of the radius is exactly 3 units. So this will be the radius length. Then using our compass, okay, we have the center at negative 2, negative 4 with radius length of 3 units. So this will be the circle in example number 2. Okay, next example. Sample number 3. Give the standard equation of the circle satisfying the given condition. Center is now at the point negative 5 square root of 3 and the radius length is square root of 2 units. We use the formula for the center at HK in standard form. We identify the value of the center, HK, and the radius of square root of 2 units. So now, what will be the value of h? H is negative 5, while k is square root of 3. Then the radius has a length of square root of 2 units. So now we evaluate the left side. So what is x minus negative 5? So negative times negative will give us a positive value. So this becomes now the quantity of x plus 5 squared plus y minus square root of 3 squared is equal to square root of 2 squared will give us positive 2. So this will be the equation in standard form. Now, we are about to draw the circle. So we begin with the center at negative 5 square root of 3. So negative 5 square root of 3 is negative positive. So this will be located in quadrant 2. Square root of 3 is approximately 1.73 units. So that will be negative 5 square root of 3, the center. Next, square root of 2 is approximately 1.41 units. So it means the radius length is exactly 1.41 units away from the center. So that will be the radius length. So this will be the circle. So it's a small circle in quadrant 2. Okay, done.